In this video, we are going to learn a process called completing the square. This is tricky. Brace yourself. Take a little walk. Do a little stretch. Be sure you're ready for this. Okay? So, to start with, I'm giving you 4 quadratics here. I want you to factor each one and absolutely use a box and diamond, but try and push yourself to look for a pattern that you could use that would not require a box and diamond. Okay? So if you don't see one right off the bat, that's fine. Do it with a box and diamond, but as you're using your box and diamond, try and figure out what's the pattern that could get us those factored forms. Did you decide that the first one would factor to x plus 3 times x plus 3? Did you decide that the next one would be x plus 5 times x plus 5? Now what's the pattern here? We've got 3s, 6s, and 9s. We've got 5, 10, and 25. There's definitely something going on here, right? Multiples of 3, multiples of 5. On this one, we've got a negative in here. That's weird, but x minus 4 times x minus 4. Now here, let's see if we can do it without doing a box and diamond. So we've got a minus 20. Up here we had a minus 8 and it ended up being a minus 4. Here it was a 10 and this became a 5. Here was a 6 and this became a 3. A reasonable person might guess that this is going to be an x minus 10 because that's half of the 20. So half of that b value goes in here. And then that 100, well, that's these two numbers multiplied together, right? 4 times 4 is 16. 5 times 5 is 25. 3 times 3 is 9. So that would be minus 10. And it works. Now, these only work because these two numbers were the same, right? This is a special shortcut for perfect squares because these all could be written as x plus 3 squared, x plus 5 squared, x minus 4 squared, x minus 10 squared. And these are what are called perfect squares because if you built them with algebra tiles, they would make a perfect square, right? It'd be the same thing on both sides. You'd have an x and a 10 and an x and a 10 on both sides. All right, let's do one more. This time I want it to be x squared plus 24x. How should I finish this? What should I put in there so I'm going to be able to get a perfect square? What number do I need? You could even think about doing this part first, right? This was always half. So this is going to be x plus 12, x plus 12, and then these two need to multiply together to get my c value of 144. Would equal x plus 12 squared. All right, so all these ones we've looked at so far have already been perfect squares. Now, if this only worked on perfect squares, this would not be a very powerful tool, right? We need something that works no matter what. You'll notice I've also only done ones that have even numbers. This is on purpose because I'm trying to not make this too complicated too fast. So let's do another one, but this time it's not going to start out just right. All right, so I'm going to take x squared plus 12x plus 30 equals y. Okay, now, I didn't have the y equals on any of these up there, but it could have had them, right? That was nothing to say that it's not a y equals. We just didn't need to mess with that part. But this time we will. So, this is not a perfect square. I know that because if I take half of 12, 12 divided by 2 equals 6. And if I square that, I multiply by itself. 6 squared does not equal 30. All right? Didn't work, not a perfect square. But I want it to become a perfect square because I am trying to complete the square. So in order to make it a perfect square, 6 squared would equal 36, right? So I can add 6 to both sides. So that gives me x squared plus 12x plus 36 equals y plus 6. And I'm just going to leave that y plus 6 over there. I'm not going to worry about it. I'm just going to let it be. Now this over here is now a perfect square. And using my pattern from up top, I can factor it. So I can rewrite this as x plus 6 squared equals y plus 6. Do we see what I did? You could box and diamond this guy, but you shouldn't need to because we can just like see the pattern, right? We know that it's going to be that 6 because it was half of 12. And then I don't want something to equal y plus 6. That's weird. So I'm going to subtract the 6 back away. So then my final answer is y equals x plus 6 squared minus 6. Look at that. It's vertex form from the last video. It means we can see the vertex. I know that my vertex is going to be a minus 6 and a minus 6. Woohoo! Completing the square on a quadratic changes it into vertex form. Completing the square gives you vertex form. All right, let's do another one. Okay, so I have y equals x squared minus 4x minus 3. I want to write it in vertex form, which means we are going to complete the square. Complete the square. Okay, so first of all, we need to figure out, is it in perfect square form already? Because that would be really nice. Well, let's check. Negative 4 divided by 2 equals negative 2, and negative 2 squared does not equal negative 3. Negative 2 squared equals 4. So what do I need to add or subtract in order to make this into a 4? 7, I would say. So I'll rewrite it. Y equals x squared minus 4x minus 3. I'm going to add 7 to both sides. Some people do this by starting by adding the 3 to both sides and then add the 4 to both sides. I'm just doing it in one step, but it doesn't matter either way. X squared minus 4x plus 4. So then over here, this is now a perfect square. So I have x minus 2. It's a 2 because that 2 up here, right? That's what makes it. You can also just do a box of diamond at this point if you're not sure. And I want it back so it's just y equals so that I can like plug it into a graphing software if I wanted to. And so I can recognize the vertex, not 2, 7. Minus 7. So if I wanted, I could say that the vertex is 2, negative 7. Okay, let's do another one. This time, we're going to make the b value be odd. It's going to work the same way, though. So first things first, is this a perfect square? I pretty much know it's not, but let's do the steps anyways. So 5 divided by 2 gives me 2.5. And 2.5 squared gives me 6.25. So that means that I want my C value here to be 6.25. So I'm going to add 5.25 because that will give me 6.25. So y plus 5.25 equals x squared plus 5x plus 6.25. And over here, my perfect square is x plus 2.5. So it's that half of the b value squared equals y plus 5.25. So I get y equals x plus 2.5 squared minus 5.25. Now, there is a major caveat here. I've taught you all these amazing things. It's this fabulous new tool. Notice, I have never once given you an a value that's anything other than 1. That's because it changes slightly when you have an a value other than 1. But just know that this only works when a equals 1 for now. Okay? So this works when a equals 1. In fact, we should probably go back to the first page and add that. So back on the first page, completing the square when a equals 1 for y equals ax squared plus bx plus c. That a value has to be 1 for this to work. All right, so for your practice problem, I want you to complete the square to write y equals x squared minus 14x plus 30 in vertex form.